The first person that we're talking about is Becquerel. In 1896, he discovered radiation. He did so quite by accident by placing a rock in a drawer on some photographic film and then coming back and noticing that it was exposed. Marie and Pierre Curie discovered polonium and radium by studying uranium ores. They both received a Nobel Prize for this. Radioactive decay is the spontaneous breakdown of a nucleus to form a different nucleus. This process gives off various small particles. These various small particles are called radiation, and they're released during radioactive decay. Remember that you need to know how to write isotopic notation. We're going to be using that a lot in this section, and that's mass number over atomic number, and then the symbol of the element. Our three types of radiation that we'll be talking about is alpha, beta, and gamma. Alpha particles can be written one of two ways, either with the Greek symbol alpha or 42He, because an alpha particle is simply a helium nucleus. So the mass is 4, and our charge, because this is just a helium nucleus, is positive 2. Alpha particles have the lowest penetrating power, and you can shield yourself from it with just paper or clothing. Beta particles can be represented with the Greek letter beta or 0, -1e. Beta particles are fast-moving electrons that are ejected from the nucleus. Because it's an electron, it has a mass of 0 and a charge of -1. It has medium penetrating power, and you can shield yourself with skin or foil. Gamma can be represented by the Greek symbol gamma, or sometimes you'll see it 00 gamma, because gamma is pure energy. So it doesn't have a mass and it doesn't have a charge. It's just a photon. It has the highest penetrating power, and you can only stop it with lead or concrete, or a combination of the two, and it usually has to be rather thick. Alpha and beta, although it looks like they can be stopped very easily, they can cause damage if you ingest them or inhale them. From this picture, you can see that alpha is stopped with paper, beta goes through the paper but stopped by skin, and gamma is going to go through paper, skin, and then notice that it's being stopped deep within the concrete. Here's a simulation of plutonium giving off radiation. If we drag foil up, notice that the blue and the middle one are going to be stopped by the foil. Paper stops only the blue one, but the middle and bottom one go through, while lead is going to stop all three of them. Given that information, we know that gamma radiation must be the bottom one, because that was the only one that was stopped with lead, just lead. While alpha radiation was stopped by paper and beta was stopped by the foil. This isn't in your notes, but you'll need to know your chemical equation and some pieces of it. So the beginning, we have reactants. Reactants are on the left of the arrow. The arrow, we'll sometimes say is yields or equals, are products which are on the right of the arrow. You also need to know coefficient, which is the number in front. And a coefficient multiplies whatever it's in front of. We'll go ahead and label subscript and state symbol, but you will not need to know those in this unit. State symbols are like solids, liquids, and gases, so that S would stand for solid. We'll see this later in the year. So we'll have the X there. Again, these two are the ones you don't need to know, but you do need to know the other 4. So let's talk a little bit more about alpha. An alpha particle consists of a helium nucleus that's been emitted from a radioactive source. They're called alpha particles because they contain 2 protons and 2 neutrons and have a positive 2 charge. So in our sample here, we have plutonium-240, and it's undergoing alpha decay, meaning it's giving off an alpha particle. So when it decays, it gives off 2 particles. One of those is our alpha particle. We set up our nuclear equation like I'm doing here on the right. You have the mass and the atomic number and the element. It decays to give off alpha and some other element. To solve this, we say 240 has to equal 4 plus something. Well, using basic algebra, we have 236 plus 4 gives me 240. And on the bottom, same thing, 94 is equal to 2 plus something, or 92. To figure out what element, I just look on the periodic table and find element 92, which is uranium. Okay, let's do some practice problems. You'll need to write these down in your note packet. All right, let's do the first one together. We have 238 is equal to 234 plus something. 4 plus 234 gives us 238. Something plus 90 gives us 92, that's 2. And 42 is alpha, which is He. I'm going to pause the video and try the next 3 on your own, restarting when you have your answer. So 222 plus 4 gives us 226, and 86 plus 2 gives me 88. 88 refers to radium. 204 is equal to something plus 4, which is 200. And 82 minus 2 gives me 80, or mercury. Bottom one, we have 216 radon. The atomic number of radon is 86. Arrow, it's undergoing alpha decay, so it should be giving off an alpha particle. And something plus 4 gives us 216, which is 212. Bottom, 84 plus 2 gives me 86. 84 corresponds to polonium. Beta radiation consists of fast-moving electrons formed by the decomposition of a neutron in an atom. So a beta particle is simply an electron. The thing that makes it different is this electron is formed in the nucleus. So how can we have an electron coming from the nucleus? The decay of a neutron into a proton and an electron. That's how we get a beta particle, or an electron from the nucleus. Our electron is going to be emitted from the nucleus, and our proton is going to stay in the nucleus. So if we write that out into an equation, we have a neutron, which is 1, 0 in, turns into a proton, which is 1, 1H, and a beta particle, which is 0, negative 1E. Notice our mass should stay the same, but the atomic number should increase by 1 because we have one more proton than we had to begin with. So looking at our example problem, we have cesium-137, and cesium's atomic number is 55. Releasing a beta particle, 137 plus 0 gives me 137, and something minus 1 gives me 55, which is 56. So in our picture, we have our beta particle and our barium-156, or barium-137. Okay, we're going to do some sample problems. We'll do the first one together again. On the top, we have 66 plus something gives me 66. That's 0. And 30 minus 1 gives me 29. Go ahead and pause the video and try the next 3 on your own. Okay, for the first problem, you should have gotten 8,5B. 6 minus 1 gives you 5. Second one, 14,7 nitrogen. And the bottom one, silver 108. Silver has an atomic number of 47. Gives off a beta particle and turns into 108 on top and 48 on bottom. 48 is element cadmium. Okay, our last type is gamma radiation. And gamma rays have no mass and no electrical charge. Therefore, the emission of gamma rays does not affect the atomic number or the mass number of an atom. Gamma radiation usually occurs with either alpha or beta, if not both other types of radiation. X-rays behave the same as gamma rays. The only difference is their origin, or where they came from. X-rays are produced when excited electrons in certain metals lose their energy, while gamma rays are produced from radioactive elements or isotopes. So in our example, barium-137 releases a gamma ray or photon. Down here, this is our photon or gamma ray. And on the top, we have 13756 barium, because the mass nor atomic number changed. If you were to receive an equation, you would see the gamma symbol with just 0, 0, or just the gamma symbol. You have to write that in there because if something is giving off gamma radiation, you'd need to be behind lead or concrete or a combination of both. Let's look at our first problem. Anytime they just give you a symbol, go ahead and add the numbers in there. In this case, it's just 0, 0, but so you remember later. 230 is equal to 226 plus 0 plus something. That number should be a 4. $88 plus 0 plus 2 gives me 90, or helium. So in this first one, we have alpha and gamma radiation being given off. Go ahead and pause the video and try the second one on your own. So we have our 0, 0 gamma, so 234 on top, and then 91 minus 1 gives me 90, and 90 is thorium. So in our second example, we had gamma and beta. There's a few more particles that we'll see sometimes given off in addition to alpha, beta, and gamma. Those are neutrons, protons, and positrons. A neutron has no charge but a mass of 1. Protons have a mass of 1 and a positive 1 charge. And a positron, if you look at the symbol, has a mass of 0 and a positive 1 charge. A positron is a little weird. It's a proton decays into a neutron and a positively charged electron. So a positron is a positive electron. So in our example, we have a positron is emitted from potassium 40. So we'd have 40 on top, potassium is K, with an atomic number of 19. It emits a positron, which is 0, 1 E. Notice that my mass stays the same, but my atomic number decreases by 1. Because I lost a proton, I would expect my atomic number to decrease by 1, which it does. I would expect my mass to stay the same since protons and neutrons have the same mass. Go ahead and pause the video and do these 4 on your own. Restart when you have your answers. So for the first one, we have alpha decay. 230 plus 4 should give you 234. And on the bottom, 96 plus 2 should give you 98. '98 is CF for californium. 236 plus 4 gives you 240, and 94 plus 2 gives you 96. So that's helium. So alpha was given off in number 2. Number 3 was a little tricky because you had a coefficient. Remember that you have to multiply the particle behind it. That means I have 2 neutrons. So 2 times 1 is 2, 2 times 0 is 0. So 44 plus 2 gives me 46. 21 plus 0 gives me 21. 21 is scandium or SC. Number 4, just like before, if they just give you the symbol, make sure that you're writing those numbers in. Because 9 plus 4 will give me 13, and blank plus 12 should give me 13. That's 1. 4 plus 2 is 6. I already have 6 on the other side, so I have a 0. And 1 0 in. Make sure that you know that that's an in. A lot of people will miss that on the test because they don't memorize those particles.